Hi folks, I figured I would try something new, so I asked the Substack admins to switch on the RMTP endpoint, and so I believe, I can't see myself, but I believe I'm live on Substack for the first time, which is quite fun. I often do a bit of live streaming over on LinkedIn and stuff, but I figured something new for a Thursday, a quick live stream about data, cloud stuff, that type of thing, over here on Substack. So, with that all being said, bear with me 1 second. I share the fact I am live on Substack with my LinkedIn brethren. There we go. Right, okay. So I told you, I've literally just switched this thing on just to figure out what happens because I figured it would be quite fun. Anyway, okay, so Protobufs. I want to talk about Protobuf because not everyone has heard of them. But for those of us who work in data, and especially data transmission sectors, Protobufs are crucial, I think. There's obviously different file formats. I'm not saying that Protobuf is zero, but Protobuf is crucial for coherent communication between different services. And so what I wanted to look at was what Protobufs are, why you might use them, why they might be better than other stuff for certain scenarios, and why I think microservices for one get bad press, and part of it is because the communication between services can break down if you don't think about it properly. And Protobufs sort of make you think about it, maybe not properly, but more effectively. So, why use Protobufs? High performance and compact size. Protobufs are designed to be serializable. They're designed to transmit data over the wire. They're not there for data storage. They're not a table architecture. If you've come for table architectures, I apologize. We're talking about serialization of data. And they serialize into a binary format, which makes it faster and smaller than the textual brethren that you also get in terms of JSON, XML, YAML, all that type of stuff. They compress, they get real small, and they reduce the bandwidth and storage costs, especially on high throughput systems. So if you've got microservices architecture or something that's just sending a lot of data all over the place, something like Protobuf can make it, more streamlined for data transfer. The other thing that's cool about Protobuf is the cross-language compatibility. So a lot of what we do today, and I saw a post about this on LinkedIn yesterday where someone was talking about how Python ends up often being a second-class citizen because of the way that enterprise architecture works and the way that businesses sort of gravitate around something that's more strictly typed. This is true, but it's also well known that researchers, not every researcher, I'm not going to bucket you all, but some researchers and people writing proof of concept code do not write it to a great standard. And so more strictly typed languages can enforce those checks and balances, those boundaries between data and structures and the way that stuff moves. A little bit better potentially than Python-based hackering when it comes to doing stuff in pandas, polars, Spark, you name it. And there's a different language for a different purpose. I'm not knocking Python either, but also in enterprises you're more likely to see something strictly typed. Now, of course, the problem is that you sometimes want to be able to have a strictly typed, more traditional programming language, Java, C++, Golang, whatever, communicate with something that is not the same language. It might be a user interface, it might be a different backend system, it doesn't really matter. But the nice thing about Protobufs is you define the schema You tell it what you want this data object to look like, and then you can compile that into a bunch of different languages. And so one of those would be Go, if that's what you're doing. Another one might be Python or TypeScript, or, you know, whatever language you choose to use. And that ensures compatibility across different stacks, even though you're sending data from one place to the other. And that's cool because that way you can have a TypeScript UI, JavaScript UI, that understands how to compile and decompile protobuf binary data that's come from your Python backend or from your Go backend or both backends potentially. And so, you know, it ensures that ability to cross those stacks in terms of structure, but also make sure that the structure remains the same because the schema is strongly typed. Yes, technically there's JSON schema. Who's ever written one? Not many. So like JSON schema does exist. But JSON, by and large, is loosely typed. People make it up and then they change things as they go along. Protobuf enforces a structured schema that can prevent data corruption and makes APIs more predictable, because if you have two interfaces and they're both compiled with the same Protobuf schema, you know that they will know how to communicate with one another. That's cool. Protobuf also allows you to add new fields without breaking older versions, which is critical for API evolution and microservices because you don't know what version of your schema the other stuff's going to be using. So bear that in mind as well. Anyone here use gRPC, Google's RPC framework? There is other stuff out there, but gRPC is often used with Protobuf because it's the default. Often helps. But, you know, if you're using gRPC for inter-process communication where you want something to look like it's part of the same process but actually isn't, Protobuf is cool at providing gRPC backwards and forwards between different services. So there's 5 reasons to use Protobufs. What tips have I got for you all? That is a good question. So, there's different ways to be able to like define fields. By default, all fields are optional unless, of course, you tell it otherwise. And so you can mark fields required. Wouldn't advise that you do that, but you can mark fields slightly different, reserved. And so if you remove a field from your protobuf file, but there's a chance that like years down the line, some other developer is going to come online and like add a field in that's got the same name, you can reserve tag numbers. And so tag numbers are like field identification numbers that go with a field. You can reserve them so that they don't get reused in the future. And that sort of helps for the evolution and the potential of schemas smashing into one another. You can use one of, this is cool, if you're trying to build like a more complex scenario, you can use one of, and so you can have like a field that's called method, and you might have one of credit card, PayPal, or bank transfer, and the one of sort of prevents multiple versions of that being set because you know there can only be one at a time. So that's always cool. So mutually exclusive field setting. The other thing you have to bear in mind is because it's strictly typed, you do have to think about data types. So, and then the other thing as well is that you're trying to like make stuff small. And so data types are important in the ones that you pick. So if you're using standard size numbers, int32, if you've got something that might be super large, int64. If you don't need negative numbers, you can use uint. Anyone that comes from a Golang background or C background will understand all this type of stuff. But like if you're just doing general data processing, it may not be obvious. If you don't want to go negative, use uint. If you're using binary data, you can use a bytes object. Literally just cram the bytes in there. And you don't have to do any type of sort of crazy munging from bytes into strings. It'll handle it all for you and then send it over the wire, which is nice. If you've got lists of stuff, you never know how long those lists are going to be. There is like a repeated key. So if you've got an items list, you can have a repeated string items, and you can have as many items in that list as you want. That creates an array for you. You can have maps. You can have like a map with 2 strings or string and int or whatever you want. There is a map type, which is useful for like configuration stuff, metadata, caching, all that type of fun stuff. Protobuf 3 has been out for quite a while now, but you might find some stuff that still works on Protobuf 2. If you use Protobuf 3, you don't need to mark stuff as optional or required, which I spoke about a minute ago. That's useful. Default values do exist, empty quotes for strings, 0 for numbers, better support for gRPC. You should use, so I do a lot of Go programming where stuff like null doesn't really exist. Protobuf sort of follows a similar setup. Protobuf doesn't support null values primitive types, which is cool because it means that you've got a guarantee again about what's in there. You can, though, use wrapper types. So there is the ability to use wrapper types which allow for explicit null handling if you need something like that. And again, you can use packed to allow for repeated primitive fields, which reduces the message size. So if you're getting really into the weeds of message size, you can use stuff like packed to like really squash that stuff down. And you can use, if you're sending this stuff over the wire, gzip or snappy compression or something like that to go with it as well to ease, like squash it even further. So it is already compressed. You can compress it further by using gzip or snappy. Some web servers and what have you will gzip your endpoints for you. A lot of them will. So you don't necessarily have to think about this. But if you're rolling your own RPC endpoint or something, depending on how it's set up, you might want to. The other thing as well is that you can keep track of versions in a structured way. There is a package tag at the top, and you can version your syntax with like Proto 3 and that type of stuff. This allows you to ensure that over time, as your schema evolves, you can ensure that you know where it came from, what it was built with, what it's compatible with. There's all some cool stuff. 3 reasons that you might not use it. If you're required to have human readability, like obviously you can transpile it into something that looks like JSON, but JSON may be better. For small scale projects, well, JSON takes less time to get off the ground, maybe. Depends how many times you've done it, clearly, but like JSON is simpler and is supported by more stuff. If you don't need the efficiency or streaming data systems, that type of stuff, you're not using gRPC, Protobuf might be overkill, but we're using it currently on a project for data transmission and validation from client side to server side, and whilst they post a data file, it's translated under the hood into something that looks like, well, it is a Protobuf file, and then that's sent to us, and that means that we know that when it lands on our end, as long as we can decode it, we'll be able to read it, which I think is an awful lot better than just trusting the people or the app to send something in your direction that's valid. So Google Protocol buffers, Protobufs, are ideal for high-performance data exchange and microservices, APIs, inter-service communication, all that type of stuff. They do reduce the data size. They ensure schema evolution, work across multiple languages, which I think is cool. Anyway, this was just a test. I figured it would be quite fun and I'd go into something a little bit more nerdy. If people want to do a deeper dive into gRPC, Protobufs, I can bring along some slides and all that type of stuff with examples, demos, all that type of thing, where we use Protobufs on a daily basis. I'm happy to set something up for a future Substack live stream. If people have interest in me continuing to do Substack live streams and have some topics, ideas, thoughts, opinions, all that type of thing, do let me know and I will be happy to facilitate other ideas. This is cool, but I enjoy Substack. Hopefully you've enjoyed my random ramblings. Thank you very much for your time. Happy rest of your Thursday, and I will see you all soon. Bye for now.